video, we're going to take a look at very basic concepts in geometry, and that is really looking at some definitions of key concepts and ideas that you're going to be using in geometry. So we're going to define those things. We're going to talk about how we name them, and we're going to look at a diagram for each of them, and then we're going to look at some pictures and see if we can look at the pictures and find each of these things. So you can take a look at the top, some of the key ones that we're going to be looking at: points, lines, planes, and a few others. So let's start off kind of just going down a list of some key terms. So we're going to start off with a point. A point indicates a location that has no size, and so that's really just a space or a spot on a line, or a spot on a grid, or a spot in 3 dimensions, just some location. It doesn't actually have size, but we're trying to indicate a location on some geometric shape. So how we name things are actually going to be very important, because we want to be able to communicate with each other using the same type of language. And so when we're going through how to name things, you want to make sure that you're naming them the same way that I name them, so when I look at your diagrams, I know what you're talking about. So when we name a point, we're going to put a dot on a paper, and we always use a capital letter, such as capital A or capital B or capital C. So we don't use lowercase letters. Those are used for other things. You just have to be careful that you're labeling them properly, so that when I look at it, I know what you're looking at. So there's an example of a diagram for a point. I would put a dot on the paper, and then I would pick some capital letter which will represent the name of that location in space. Okay. So your second definition is a line. Okay. A line is a straight path that extends in 2 opposite directions without end and has no thickness. So again, there's this mention of the size of a line. So it's got size going in one direction that connects those points together, but it doesn't have thickness. We can't say, even though this picture, which I'll show you now, looks like it's thick. That's just our way of drawing it. We have to show it, but it doesn't necessarily have any thickness to it. Okay, so to name a line, we actually have a couple of different ways, and how you name them depends on the situation, really, or maybe just your personal preference. So one way that you could name a line is to pick any 2 points on the line. So you can take a look at my diagram over here. I have a point A and a point B using capital letters, and so I can call this line AB. Right? I could also call it line BA, because it doesn't matter what order I say those points, they're still on the line, so it still works. Okay? If there was a third point on here somewhere, I could also use that one instead. So as an example, I could come up here and add another point and say there's a point in here called C, and I could also call this line CB or CA or AC or BC, and those would all be valid ways of naming it too. We'd be talking about the same line, even though we're using different points to name it. Okay. The other possibility is if we want to use a single lowercase letter, usually down at the edge of the line, you can do that as well. And a lot of times this is used in cases where there's maybe not a point on there at all, so we don't have points to name them. So let me give you an example of something like that. If I were to just do this line and I were to say give this a name, well, I didn't put any points on this line that are labeled, and so we don't have any way of using this method in order to name this line. And so I might have to call this, like, for example, like line Q, right, or line R or line S, and I'll just put that lowercase letter down at the edge of the line. Okay, so that's just a kind of another example. Here's the last little point. In this particular problem, and you'll see on others, there's actually a line written above the 2 letters, and that's really important, because if that's missing, or if you don't have the arrows on the end in our language of describing geometry, that would mean something else. So you want to make sure that you're specific. You put the 2 letters down, and you also put the line with the arrows over the top, so we know what you're talking about. Okay, here's your last one. Before we look at some examples, and that is a plane. A plane represents a flat surface that extends without end and has no thickness, okay, and it contains many lines, right? So to name a plane, you are going to use a capital letter without a dot. And so this is, again, something that you have to be careful about, because it might look similar to a point, which also uses a capital letter, but if it doesn't have a dot, we know that we're naming the plane. So here's your example here. If you take a look, this capital P does not have a dot next to it, and it's usually up in the like corner of the plane. That would indicate that that is the name of the plane, whereas the A, B, and C all do have the dots next to them, so I know that that's a point. Okay, so I could use that capital letter that does not have a dot next to it as the name, or if you pick any 3 points in the plane that are not in a straight line, you could use that. So because I can't draw a straight line between A, B, and C, like I could draw it between A and B, but then I miss C, or I could draw it between A and C, but then I can't get B in there, right? So because I can't draw a straight line that hits all 3 of them at the same time, I can use these 3 letters, and I could just call it, use the word plane, and then A, B, and C. Okay, some people use more letters, but typically it's 3 letters. Okay, so just some things to note. So here's a couple other definitions that we're going to use: the words collinear and coplanar. So collinear is actually used to describe what we were just talking about a second ago. Collinear points are points that are on a straight line. So if I can draw a straight line and hit all of those points, I would call all of those points collinear. And if I can say that all of the points or lines are in a plane, I would say that those points or lines are coplanar. Right? So that's our way of describing things that lie in a line, or things that lie on a line, or things that lie in a plane. If I was talking about things that did not lie on a line or a plane, I would just put the word non, or the prefix in front of it. I would say non-collinear or non-coplanar to describe things that are not in a straight line or not on the same plane. Okay, so let's take a look at a picture. Okay, so these pictures are actually a little bit tricky to interpret when you're first looking at them. So when I'm looking at this, I'm seeing, if you can visualize, like a flat piece of paper. Okay, and on that flat piece of paper, which they called P, right? This is plane P. Okay, they drew a line, like with a pencil. They just drew it on the piece of paper, and that's what this line right here is indicating. It's actually flat on the same surface as the plane. Okay, that, or at least that's what it appears to be. That's what we're going to assume. This other line, however, right, which we would call TN, okay, that one is not being drawn on the piece of paper, and that's really tough to see because we're looking at it on a flat screen or a flat board or whatever, and so look, we can't really tell. The way that we know that is this little dotted space here. What this means is that if this plane was solid, we would not be able to see that. So let me see if I can give you kind of another quick example. All right, usually we use like a parallelogram of some type, a 4-sided shape to draw a plane. If I want to indicate to you that this is like kind of being stabbed through the plane as opposed to laying flat on it, I would draw it like this. Okay, but then because the plane's here, you can't see the rest of it going through to the bottom, and then you would start seeing it as it comes down here, right? So that would be a line that is going through the plane but not laying on it. So we usually want to show you the entire line, so we add that extra dotted line in there to say this is actually hidden behind the plane, and the only way that it can be hidden behind it is if it's not laying flat on it. So that's just kind of like a quick lesson in how to look at a 3-dimensional shape and indicate kind of what they're trying to show you when they draw it. Okay, so let's answer their questions really quick about naming points, lines, and planes. So they're talking about this line QT. They picked 2 points on this line, and I know it's a line because I have the double arrows over the top of it. And they want 2 other ways that we can name QT. So here's some other examples. I could pick different points on the same line. So T, Q, and N are all on this line that's poking through the plane. So I could pick any 2 of them. So for example, I might call this NQ, okay, and put the arrow over top of it. I might just switch the order of this one and call it TQ instead of QT, and that's also okay. I could also use the lowercase letter that's sitting down here at the end of it, and I could call this line M, right? So there's 3 ways. They asked us for 2, but we're allowed to do more, okay? What are 2 other ways of naming plane P? So they're using the capital letter without the dot to name the plane, but we can also use 3 letters that are not in a straight line. Remember, we use that word collinear, so 3 letters that are not collinear. So I could use this V, for example, and I could call this plane, okay, VRQ, and that would be fine. I could call this plane, pick different letters, SQV, and that would work as well. So any 3 letters. I couldn't use RQS because they make a straight line. Right? I also could not use or N because those lines are not on the plane at all. So be careful that you're using 3 letters that are on the plane, and make sure that all 3 of those letters don't make a straight line, and then you're good to go. Okay, so 3 collinear points. Well, we just gave that away. We talked about R, Q, and S. Those are collinear. I could also talk about T, Q, and N. They are collinear, but on this up and down line instead of the one that's flat in the plane. Coplanar points, I could talk about R, V, Q, and S all lay on this plane P, and that would be an example of coplanar. Okay, so let's wrap up by doing a couple of more definitions. Okay, and so here's our last few definitions. So we can move on and start using this stuff. So we could also talk about, instead of lines, we could talk about line segments. And so what that means is we said in our definition of lines that lines go forever in both directions, and we indicate that with the arrows on the ends of those lines that just say, you know what, we can't draw them forever, but we're just going to tell you that they're going to keep going forever in both these directions. A segment, we're going to change it up, and we're going to say, you know what, we want this to end on both sides. So if you see this word endpoints, that means we're going to cut off those arrows, okay, and we're going to make it look something like this diagram where we're saying it does not travel forever in both directions, it stops. And so the difference here is we can actually measure now how long a segment is, whereas a line goes on forever, so we can't actually get a measurement of its length to use in a problem. Okay, how we name a line segment is very similar to how we name a line. We're still going to use 2 letters, but because this has endpoints, we're going to have to use those endpoints. On a line, we were able to use any 2 points on the line itself. With a line segment, we must use the endpoints. Okay. It does not matter what order you put those endpoints in, so A, B, and BA are both okay. Okay, and if you notice again at the top of this, we drew a line, but because this is not a line anymore, it does not have the arrows on the end of it. That's how we indicate line segment. We don't put the arrows on. So little detail, but just be careful about that. Okay. We could also have an array that consists of only one endpoint. So lines don't have endpoints, they go forever in both directions. Segments stop on both sides. Array just stops on one of the sides, but on the other one it does go on forever. So take a look at a picture of array. Okay, it could look like this. So it stops on one side but goes forever in the other direction. So naming array is probably one of the trickiest of them. Okay, you're going to name array by writing the one endpoint that you have. So in this example, we must start with the letter A. That is the endpoint. And then we can pick any point that is in the direction that the arrow is traveling. So any point that is on the ray, it doesn't matter which one you use. Okay, so for example, in this one I'm starting at A, and I'm traveling in the direction of B, so I'd call this ray AB. Okay, I could put another point in here, C, and it would equally be as valid to call this ray AC, because C is also on the ray traveling in the direction of that arrow. So you can name it many different ways if there happen to be more than one point on the ray itself. Okay. Here's the other little thing, and this is just minor details. We have an arrow at the top. The arrow is always pointing to the right. It doesn't. If I had a ray that was traveling in this direction, I wouldn't necessarily have to draw that direction above the line. We just use a right-hand arrow all the time. But the key important point is that the endpoint must be first. Okay. So here's your last one, and that is what's called opposite rays. Opposite rays are 2 rays that share an endpoint and form a line. So if you take a look at this picture here, it kind of just looks like a line, but what we did was we took a ray that starts at C and travels in the direction of B, okay, and we combined it with another ray that starts at C but travels in the direction of A, okay, and when I put those together I get a straight line, which means there's no bend at C. We'd call that an angle when we bend it. There is no bend, so we're going to say in this case CA and CB are rays that travel away from each other, and they're connected by that point C. Okay, so I'm not going to do any additional examples with segments, rays, and lines. Okay, I'm going to put up a picture of one where you can ask some questions. What are the names of these? But I think it's pretty straightforward at this point, so I'm not going to go through and do all these problems. If you want some additional practice, you can come and see me and we'll do those in class.